Hi, my name is Leon Starr, and welcome to video 6 in the Road Subsystem Modeling series. In this video, we'll tackle the diverse usage of driving lanes using a new and powerful modeling technique. In our previous video, we modeled known and reasonably stable categories of non-driving lanes. Now we're going to put the focus on lanes where we are allowed to travel. We want to avoid doing a case-by-case inventory of every possible driving lane usage, so we're going to begin with a stable categorization. Looking at the street view and many others, we can see that a driving lane can be either restricted or unrestricted. Only certain classes of vehicles can use a restricted lane. Buses, for example. And what about that left turn lane in the middle? Certainly special rules apply there, but we're actually going to handle that in the intersection subsystem, and that'll be a future video series. Now for that modeling trick I've been promising since our previous video. We're not going to subclass restricted driving lane any further. We simply cannot inventory and categorize all possible driving lane restrictions. If we did it one way today, we'd want to do it another tomorrow. So we don't even try. Instead, we observe as many restrictions as we can and abstract the finite set of parameters necessary to define a restricted lane usage. We can observe, for example, that each restricted lane is some combination of a vehicle class, time periods, and activity restriction. We can then define that collection of properties as a restriction specification. So let's see how this might work. Let's see what components we might need for our restriction specification. We start off with the vehicle class, and some example instances might be truck, car, taxi, ambulance, and so forth. The other component of our specification is the lane usage, where examples could be carpooling, parking, pickup and drop off, and so forth. Finally, we model the time periods. Weekdays between 7 and 9, 4 p.m. to 6 p.m., etc., when the restriction specification is in effect. Since this schedule defines when the restriction applies, we'll call it an application schedule. We'll actually need at least one more class and a one-to-many association to represent the multiple time periods, but you get the idea. Now, how do we bind all this together to define a complete restriction specification? Well, we just use relationships like we've been doing all along. So we could say that a restriction specification permits occupation of at least one vehicle class. Because, of course, if there is not at least one, we certainly don't have a driving lane. And any given vehicle class may or may not be permitted in any number of restriction specifications. Similarly, we can say that there may be any number of lane usages permitted. Now, we presume that the activity of traveling is always allowed, since otherwise, again, we would not have a driving lane. So we have hollow arrows on the lane usage side also. Finally, we need a single application schedule. We only need one, since the schedule itself will describe multiple time periods. And there must be one, even if it specifies full coverage of 7 days a week, 24 hours a day. Let's take those bus lanes we saw in our example earlier and build an appropriate restriction specification for them. Let's first make sure we have a bus vehicle class. The usage would just be traveling, so we can skip lane usage. And let's say the bus lanes are open to all traffic outside of these hours. We can call the whole collection a mass transit lane. We could similarly define any number of other restriction specifications that we could apply to specific restricted driving lanes. Okay, now we say that a restricted driving lane, by definition, is limited according to its specification, and that the same specification could apply to any number of restricted driving lanes. Let's instantiate the two bus lanes. Remember that we use the bounding lane divisions and road segment to name each of them. And for each of these, we filled in the required restriction specification field, as determined by our model, which is our newly defined mass transit lane. And now for the magic. We can use these semantic building blocks to accommodate a type of restricted lane that we've never seen before. Let's say we encounter a horse lane for some reason. Okay, well, we can just instantiate the vehicle class horse, maybe a lane usage such as, transport butter, and maybe only on Sunday mornings, for which we already have a schedule instance. We then combine these elements to form our horse-only specification, which we can relate to any relevant instances of restricted driving lane we encounter. To summarize, our model structure, that is the classes and relationships we choose, need to be rock solid. They make incontrovertible statements about the physical or logical laws of our driving universe, and we need these to ensure safety. But they don't, and shouldn't try to itemize the endless variations that are legal within that framework. One last note. Our official model currently stops with the restricted driving lane as a placeholder. I just wanted to show you our approach for modeling a restriction specification, but if you look closely, you'll see lots of problems with the model I just presented. For example, why not model the usages forbidden in a restricted driving lane? Might we encounter a restricted driving lane with dual personality such that it has two distinct restriction specifications applied in mutually exclusive time periods? If so, how do we constrain the model to guarantee such mutual exclusion? These are all solvable modeling problems, but this is work that remains to be done. So let's take stock of those parts of the road subsystem that have been modeled. In the background, you see the complete class model diagram for the road subsystem. The grayed out regions either haven't or won't be covered in this video series. It's too small to read here, but we can use the diagram to show how all our modeling pieces connect up. Note that there is a bit more detail in the actual model than the simplified pieces we've been presenting in the videos. We started off this video series by defining roads and road segments. Remember that road segments are necessary so that we can assign left-right edges to all roads visible to the ego vehicle and relevant to its orientation. The roadmap specification is a placeholder that can be modeled out further in the future. For now, we just know that each road is defined by some sort of map road designation. Next, we defined the way traffic flows within a road segment. We broke unidirectional flows down by conduit and established that there are only two possible conduit arrangements, basically one-way or two-way. We also have a road segment without any enforced traffic direction and thus no conduit. We can also break a road segment down by lanes. If there is a conduit, it is divided into one or more lanes. A shared road will be considered as a single bidirectional lane, and a lane was defined as the space between lane divisions. We then put the focus on unidirectional lanes, which are either driving or non-driving. Non-driving lanes are where we don't travel, and we were able to itemize some stable categories. And finally, we have driving lanes either as restricted or unrestricted. Rather than itemize each type, we've determined the semantic building blocks necessary to define any combination of restrictions. And at this point, that is just a placeholder that remains to be expanded. If you look closely, you may notice a lot of text on the class diagram. In the videos, we haven't said much about the attributes on all those classes we've been presenting. You can dive deeper into the details by downloading and studying the complete model diagram and the written and painstakingly illustrated model descriptions. All right, next up. We haven't said anything about bidirectional lanes yet, but rest assured we've modeled them. So in our final road system video, we will take a closer look at those. We'll also take a look at medians, and then revisit our bus stop road segment example and see if we can account for the entire road structure.